Welcome to another video from explainingcomputers.com. This time we're going to take a look at this, the Banana Pi BPI-F3, which despite what it says on the box is a single board computer and it's got an octa-core RISC-V system on a chip. Specifically, the SoC on this board is a Keystone K1 from RISC-V pioneers SpaceMIT, who have recently announced their RISC-V MuseBook laptop, their RISC-V Mini ITX MuseBox desktop, and their RISC-V Muse Pi SBC. These will all run Bianbu OS, which is a Debian distribution optimized for RISC-V processors. And guess what? The Banana Pi BPI-F3 also runs Bianbu OS, so we can try it out. So let's go and take a closer look. Right, here we have our BPI-F3, which I think is supplied in one of Banana Pi's smart router boxes, as it's larger than their SBCs. But don't worry, our new RISC-V computer is most definitely inside. And in case you're wondering, this cost me $88.83 from AliExpress, plus taxes, but with free shipping, which all came to £88.39 delivered here in the UK. And I think this is a good price for an octa-core RISC-V development board, particularly given what RISC-V development hardware cost just a few years ago. So let's open this up. Very simple. Oh look, it's inside. Let's get it out. And the bag here is sealed, so let's bring in Mr. Scissors and just cut in. Always very exciting opening new hardware, particularly RISC-V hardware. Here we are. Come on, get it out, get it out. There it is. Here is our new RISC-V single board computer. And I think we should just take a moment to put it down over here next to the two RISC-V single board computers I've currently spent the most time with, namely the Star5 VisionFive 2 and the SpaceMIT Lichee Pi 4a, both of which are quad-core boards, whilst the Banana Pi BPI-F3 is octa-core. And it's important to stress that this board, none of these boards are competitors to a Raspberry Pi, to a mini PC. They're very much RISC-V development hardware, but I know people like to see relative sizes, so here is a Raspberry Pi, which is much smaller than our new Banana Pi RISC-V board. And it'll be very interesting to see how the performance of this board compares with the RISC-V boards I've reviewed previously using currently available software. As noted earlier, at the heart of the BPI-F3 is a SpaceMIT Keystone K1 system on a chip. This has 8 of SpaceMIT's own 64-bit x60 RISC-V cores, which it claims are 30% more powerful than an A55 ARM core, whilst being 20% more energy efficient. However, right now I can't tell you their clock speed, as I can't find it in any documentation from either Banana Pi or SpaceMIT, and I have read many different web pages and data sheets. But from these I do know that the GPU is an IMG BXE232 clocked at 819 MHz. This is a RISC-V compatible GPU, well, I guess it has to be, and it supports OpenCL 3.0, OpenGL ES 3.2 and Vulkan 1.2, as well as providing H.265, H.264, VP9 and VP8 4K video encoding and decoding. Finally, when it comes to AI, the K1 does not have an MPU. However, its x60 RISC-V CPU cores include 16 extended instructions to deliver 2 TOPS of AI computing power. Also on top of the board, just up from the SoC, we have our RAM, which is 4GB of 32-bit low-power DDR4. Although it's worth noting, there's also a BPI-F3 with 2GB of RAM, and that the K1 SoC here can support 16GB of memory. A little further away, we then have 16GB of eMMC flash storage, and up from that, a mini PCIe connector, which is single-lane PCIe 2.1. And then, as you probably spotted, we also have an onboard wireless module, and in the documentation this is noted to offer 2.4 and 5G Wi-Fi and Bluetooth 4.2. However, the chip is an RTL8852BS, which offers Wi-Fi 6 and Bluetooth 5.2, which I'm guessing is the actual specification. Turning to the main lung edge, we find a full-size HDMI connector, which, as far as I can ascertain, has a maximum resolution of 1920 by 1080 at 60p, and we then get 4 Type A USB 3 ports and 2 1 gigabit Ethernet sockets. Finally, there's a barrel jack for powering the board with a 12 volt 3 amp supply. Spinning 90 to the first short edge, there's also a 2-pin header that can also be used to power the board, which is a nice touch. And we then find a 26-pin GPIO connector, a 3-pin UART header for debugging, 2 wireless antenna connectors and 2 speaker connectors. With a second quarter turn, we also get a 3.5mm audio jack, a microSD card slot, 3 switches, which are for power, reset and eMMC flashing, some indicator LEDs, and a DIP boot selector switch. Finally, there's a Type-C USB-C port, and this again can be used to power the board with a 12 volt 3 amp supply. So we have 3 power connection alternatives. On the second short edge, we find headers for 2 MIPI camera serial interface CSI connectors, one of which is populated with a connector, and this is how it's supposed to be. The other is listed as an option. And then along from these we have a MIPI DSI connector for connecting an LCD panel, and then we have 2 connectors which are labelled in the specification for providing SATA power. Returning to the top of the board, there's also a 3-pin fan header here, although in demo videos posted by Banana Pi, they didn't even have a heatsink fitted, let alone active cooling. And so I think I'm going to go the passive route, fitting this 40 by 30 by 10 unit, which is actually 2 of these 30 by 20 by 10 units stuck together, and I'll attach this later. But before that, if we turn the board over, there's a little bit of excitement left underneath, and specifically under here we have a SIM card socket, we have 2 microphones, and we have an M.2 slot. And this is M-keyed, 2-lane PCIe 2.1, and it can take an NVMe SSD. However, this slot also supports a JMB582 SATA expansion card, which is presumably why on the top of the board we have our SATA power down here. And so there we are, the Banana Pi BPI-F3, a well-specified RISC-V development board. Greetings! I've now mounted the F3 on a base board, as you can see. I've fitted the heatsink, I've installed Bianbu OS on a microSD card, and everything is connected up and ready to go. So let's bring in the video output and turn on the power. Here we go. What are we going to get? Black screen, but oh look, we've got a Bianbu OS logo. I quite like that, the bee and the little boat. That's nice, isn't it? And I'll show you the boot in real time so you can see exactly the performance of this system. Remember, we are booting here though from a microSD card. And whilst things boot up, it's worth noting that everything here was really easy to set up. Far easier than is sometimes the case with an ARM SBC, let alone a RISC-V SBC. So all I had to do was to flash an image to the microSD card, which then booted first time with no issues, nothing had to be set. It ran a first run wizard, and then I just had to create a user account, change some language settings, resize the file system, and there we were. And as you can see, here we are. Just to select me and we can log in. I've got a password like that, and we will arrive on the Bianbu OS desktop. And I have made a few scaling changes here. This is not my first boot, but other than that, everything you're about to see is exactly as you get straight out of the box when you've installed the Bianbu OS desktop image. And we're nearly there. Oh, almost there. Come on, there we are. We've arrived. And here we are. And this is a very nice operating system. And just go down the bottom here and launch the file manager like that. There we are. And what to do is just to show you, if I pick up this window and move it, very, very fluid. I'm absolutely convinced the desktop here must be GPU accelerated because it's just so smooth, so silky. It has to have a GPU accelerated desktop in Bianbu OS. And let's just launch LibreOffice Writer. Always have to do that. Check we've got a working word processor. And I'd note that this system, one of the things I've really noticed about it, it's very, very stable. I've been experimenting with this for a few days on and off, coming back to it, and it has never ever crashed. It's had a few moments of hesitation, but it's never crashed. It's always just kept going, and that's very impressive for a RISC-V distro. Let's just say hello, because we always have to do that. It is the law in these videos to say hello and make it very big. Can we do that? We can. That's absolutely fine. So we'll just get rid of that and run up the system monitor. Here we go. And this will answer a query we had earlier about the speed of the CPU cores, which we can see here is 1.6 gigahertz. That's clearly the base frequency, although I suspect it's the overall frequency. We'll come back to that in a second's time, but I think that is the standard frequency. There's just one frequency for the CPU cores. There's no boost available. And we can see our temperatures, pretty good, about 37, 38, something like that. I did try running the board without a heatsink and it idled along at about 42, 43, but I'm very happy with these temperatures in the higher 30s. But I think we'll just minimize that and come back to it in a second. As I'm sure you would guess, we're running here a GNOME desktop, specifically GNOME 45. At the top, we've got the usual kind of stuff. Let's just go into settings like that. Again, it'll come up in a second. I'm sure the microSD card is the reason this is slightly slower. Here we are definitely running Bianbu OS. We've definitely got our 8x60 RISC-V cores. And if we look at system details, as I've just said, GNOME 45, 64-bit. We've got our BXE 232 GPU. Nothing here is anything other than we would expect. If we go up to top left, we've got applications. Quite a few things here are pre-installed. It includes Solitaire. Look at that, Solitaire is pre-installed and ready to run on a RISC-V system. That's very good, isn't it? So we can start doing a bit of Solitaire like this, although I will constrain myself and close that down and go back into applications just to show you we have also installed Shotwell for looking at pictures. We've got Thunderbird as well as our web browser, LibreOffice as we've seen. A couple of AI related things, we'll come back to those in a second, and Rhythmbox, and then down in the utilities we have got disks here. And I'll just show you this because this is what I use to resize the partition on the microSD card after setup. Just went to the card down here, went to that partition and went to here and resize, and it was all the way down here, and I just dragged it up. I'll cancel this now, but that's the way I resized the partition. I didn't even have to mess around in my terminal to get this system working absolutely fine. Final thing we haven't done here is to launch a web browser. We've got a Chromium down there. It'll take a second to come up, but it'll get there. I do like this desktop image as well. It's very well presented, Bianbu OS. There we are, we've got to the Chrome browser. We've found Explaining Computers. And I bookmarked a few things to show you. Let's go to bookmarks, and they're in other bookmarks for some reason. First of all, here is the Banana Pi BPI-F3 wiki. This is where I got the software from. It's down in the Linux images. All that to download. Armbian is available too, although I've yet to try that. Go back to our bookmarks. We've also got here, there we are, what else? I've bookmarked the GPU internals to see about hardware acceleration. And we've got quite a bit of hardware acceleration here, including video decoding. That's good to see. And that inevitably leads us towards testing out GPU performance. So first of all, let's just go down here and bring up the WebGL Aquarium test. Here we are, see how many little fishies it can get spinning around, swimming around nice and quickly. And what's it doing? 500 fishies here, and it's achieving about 32, 33, maybe a bit less frames a second. Remember, we've still got the system monitor running here, but this is running absolutely fine. And I'm sure you want to see YouTube because we always take a look at YouTube. A desktop system these days has to be able to play streaming media in a browser, so let's do a test. And I'll just speed on through till I've got this running. And here we are running 1080p. There are some drop frames, but it's pretty smooth, perfectly watchable. I've certainly found that 720p playback is very good on this board, and 1080p, as we can see here, is pretty good as well. I'm quite impressed with streaming media playback in Bianbu OS on the Banana Pi BPI-F3. And the final thing I think we should look at is one of these little AI test programs they've included on my desktop here. So what I'm going to do is to plug in a webcam like that, just a normal USB webcam, and we'll run up the object detection program like that. See what that can do. There it is. Look, it's come up and it's doing its thing. Should give us a preview window in a second, I would hope. And there it is. Look, there's a picture of me. Hello. And in theory, it'll detect objects. Might be it's detecting me as a person. Look, it can detect that as a remote control. That's pretty good. What about a cup? Does it think that's a cup? It thinks it's a phone, doesn't it? It's not a phone, it's a cup. There we are. Never mind. Everything comes up as cell phone these days, doesn't it? And scissors? Hopefully scissors. There we are. That seems to be working. And I think we'll just go back to the system monitor down there, because our CPU cores, at least some of them now, are running quite high capacities. We see over here and over there. And therefore, I think we have a pretty good indication that we don't go faster here than 1.6 gigahertz on these cores. Anyway, there we are. This is Bianbu OS running on the Banana Pi BPI-F3, which provides us with a very nice, a very stable RISC-V desktop development platform. Now, there are many experiments I want to conduct with this new RISC-V SBC, but this video is already becoming rather long, and so we're just going to do a couple more tests, and then I'm going to make another video about the Banana Pi BPI-F3, which will upload 2 weeks after the first one. So for now, what I've done is I've installed an NVMe SSD, and I've been trying to get the board to boot from this drive, but I can't do that. And to be fair to Banana Pi, there is no information in the documentation about booting from an NVMe drive, only a microSD card or the eMMC. So even though we've got this boot selector switch, right now we are still here booted from a microSD card. But we can do some speed tests. So here is the terminal. Let's first of all just do an LSVLK, show you the drives now on the system, which are the microSD card we're booted from, a SanDisk Extreme Pro, the onboard eMMC, and our NVMe drive. So let's just clear the screen and first of all test the speed of the micro SD card like that, and see what we get. Very exciting. Oh, it's doing things. Come on, give us a result. There we are. 81 megabytes a second. That's not too bad for a microSD card speed on a single board computer. And we'll now move on and do the same thing with the onboard eMMC. Here we go. This, of course, will be faster. How much faster? How fast is this eMMC? Oh, that's not bad, is it? 240 megabytes a second. I might actually put the operating system onto the eMMC. It's not that big at 16 gigabytes, but I may well experiment with that. But for now, let's finally test the speed of the NVMe SSD. I've got that in the buffer somewhere. There it is. And here we go. This should be faster again. Remember, this is PCIe 2.1, which is the same speed as PCIe 2.0 and a 2-lane interface. And there we are, a speed of 617 megabytes a second. That's not too shabby. We've got some pretty decent storage speeds to play with here on the Banana Pi BPI-F3. And with that, I'm actually on the drive here, the NVMe drive, which I've called Stanley. Here it is. On this drive, I've got some media files just for a test. Here's a 2docs test. Let's play our 2docs clip. This is a 4K clip. It'll just show local decoding of 4K footage, and clearly this works. We are on a 1080p display, but this is 4K footage, and that works absolutely fine. Oh, I do like this footage of the docs. So there we are for now. That's the end of our testing of this exciting new piece of RISC-V hardware. The Banana Pi BPI-F3 is a welcome addition to the growing ranks of RISC-V single-board computers, and it's been great to try it out running Bianbu OS. Now, it's important to stress that the BPI-F3 is a development board for RISC-V. It is not a competitor to a Raspberry Pi or a mini PC, something like that. This said, we can clearly see progress continuing to be made, and rapidly, in the area of RISC-V end-user computing. We aren't there yet, but in a few years' time, it seems very clear to me at least, we are going to have consumer products with RISC-V processors being used as small desktop PCs, media players, things like that. But now that's it for another video. If you've enjoyed what you've seen here, please press that like button. If you haven't subscribed, please subscribe, and I hope to talk to you again very soon.